Okay, and we're going to count from one point to the next. So we have to go up or down to get to the point. We have to go down. So that's 1, 2, 3, right? So that's a -3 going down.
Over 3.
So now we can't just say over, we have to say right or left.
Right.
So we have to go to the right. Let's see. 1, 2, 3, 4, 5, 6. So that's a +6. So my slope
-3, 6.
is equal to -3 over 6, which can be reduced to -1/2. Now, if you use it to put in the formula, we just be subtracting the x's and the y's. So that'll be -3 minus 0. And if I go from -3 minus 0, I have to do what? 0 minus what? So that's really 0 plus 6, isn't it? Because the negative and negative make a what? Positive. And doesn't that give me -3 over 6 again?
Yep.
Which is really -1/2. So we get the exact same thing. Right, follow? So we have, either way, you're going to get the answer. If you can find the x-intercept and the y-intercept, that's the easiest way to go. But you can find any point that fits on the grid between two grid lines, and it'll work. So if somebody picked this one and this one, it would give us 1 over 2. -1 over 2. All right. Let's get out what we picked up today, which is going to be our characteristics of relations and functions. We need to make sure we pay close attention to what's going on today, because a lot of this is going to be repeat of what our were, and a lot of you didn't pick up on how to do it. We didn't do too well on our test. So we need to make sure we're paying attention. Now, when we're talking about the Cartesian coordinate plane, remember that's just where we graph. It's a flat surface. We're asking to label each axis. So what are my axes on this particular graph? What are my axes? X and Y. Where do I put the X? On the horizontal line, so we put our X here. And where do we put our Y? Vertical. Okay, it asks us to label each quadrant. Where is quadrant 1 at?
Top left.
Yeah, it goes counterclockwise. You're exactly right. So we're going to start over here. We're quadrant 1. And then this will be what? Quadrant 2. This would be quadrant 3. And this would be quadrant 4. Then we have to indicate the coordinates would be positive or negative in each quadrant. So on quadrant 1, my x is going to be what? Positive. We put a plus sign. What is my y coordinate going to be? Positive also. So these should be 2 positives. What about in quadrant 2? What's my x going to be? Negative. So we put a negative sign. And my y is going to be positive. Quadrant 3. Negative and negative. And what about over here? Quadrant 4. Positive, negative. Questions about that? Now the next few pages are just asking us to define those terms and give a representation of them. I'll start you off. I'll do the ordered pair, because I know you can take care of the order. The ordered pair I'm going to pick out is going to be any one that I choose. I'm going to say, I'm going to make it a +4, 2. That'll make it a +4, 2. So we're going to say, this right here is a +4, 2. That is an ordered pair. So when they ask us to define a verbal description, we say an ordered pair And then you have to do that for all of them. What's a relation, by the way? Relation is just a set of what? A set of ordered pairs, also. Did we spend all class period defining terms? So you should have all these, right? Yeah. So you have all of them. They just want you to give a graph on the representation. The one I want you to go to what about discrete and continuous? What's discrete going to look like when I graph them? No. It's not going to have a slope. It's going to just have what?
A line, straight line.
It's not going to be a straight line, but then that would have something going on. What would discrete look like? Just points where?
It points everywhere.
Just everywhere. So I can have just points everywhere. It has no rhyme or reason. Yeah. What about continuous?
It makes a line.
It makes a line and connect. Continuous would be something like that.
And
It can have a starting point and a what? An ending point.
and the way you figure out if it's continuous, you go like a line.
No, the only way that you would know that it was continuous is if it came up a graph that looks like this. Okay? It has to already be connected. Bless you, by the way. It has to already be connected. Otherwise, if they're just points everywhere like this, you don't connect them just because they're points. Okay? You do not connect them. So in discrete, you do not connect points. I just go connect one. Do not connect points. That's how I know that I have discrete gap. If it's already a graph that has something, I don't care what the figure looks like, but if it has a starting point on the ending point, if they have arrows on the end, it could be something that looks like this. That's a ray, isn't it? That's still continuous. It has a starting point and then it just goes on. But it's got some type of connection. What about increasing and decreasing? What's going on with increasing and decreasing? Yeah, I can do a positive slope for increasing, and for decreasing I can do what? Negative slope. What else could I draw for increasing?
A line.
I can start right here and then do what to my line?
Take off the graph.
Take it up, right? What about for decreasing? I have to start where? At the top and do what? Go there. That's decreasing there. But you have to draw me an example of what it looks like. Everybody got me? Okay. Let's go to the next part. Function notation. Function notation. Function notation just means that instead of me having a y, I'm going to have a what? F of x. That's the only difference. Instead of me having a y, I have an f of x. That's the only difference. The only difference. So, if I have f of x is equal to 2x plus 3, that just means that's the equation. I want to find out if I input a 4, what the new value is going to be. I want to find out if I input a negative 1, what the new value is going to be. And you don't know that yet until we input. Okay? You won't know that yet until we input. So, this is how they want you to fill it in. The first one, we're going to fill in a 4. So we're going to put a 4 right here. So that means wherever I see an x, I put a 4. So that says 2 times x, so that's going to be 2 times what? me say 2 times 4 is 8. 8 plus 3 gives me 11. So anytime I input a 4, I get out an 11.
Sorry.
So when it says, so the ordered pair, you put the x first, which is a 4, comma what? 11. We input a 4, we get out an 11. We put gas in our car will do what? Go. Now what are you going to put over here? -1, you do the same exact thing. Now down here they give functions different names. They give it an H, a G, and another G. I think it's this -1. Is that a -1? +1. So that means it wants us to use the G function. So where that X is, I'm going to replace that with a what? Okay, wherever I see a G, I'll have an A plus 1. So when I rewrite this G function, which is this one right here, everybody see what I highlighted? That's the one we're working with. Wherever I see an X, I'm going to put an A plus 1. So that's going to be A plus 1 squared. Where did I get that squared from? That X. See, everybody see that it was squared? So it had an A plus 1. So we put an A plus 1 here, so we have to put a 2 on the outside. And then we have to put also a plus what? 2. Plus 2. I got it. Now, I want to show you something to get your answer for this one real fast. Make yourself a little window. We call them boxes. I got it? And that just means to write this twice. So we're going to put A and a 1 here, and A and a 1 here. And you remember in elementary school, you put your finger on this, and you say, okay, if I multiply this and this together, I'm going to put the answer here. So if I multiply A and A together, how many A's is that all together? A squared. Everybody follow me? Then we're going to do A times 1. What does that give me?
A.
1A. Always put the number first.
So we just put A.
You can just put A also. You're correct. And then we have A times 1 again. That gives me 1A. What about 1 times 1? 1. So we take everything out the box now, so we can start out with A squared. Now we're going to get the answer. Everybody ready? We have A squared. And if you notice, 1A and 1A are like terms.
2A.
2A. Why didn't you tell me A squared?
Because it's 2A.
It's 2A. We're not multiplying. The only time you would get A squared is when you multiply A times A. But you added 1 plus 1, which gave you 2 of. And then what's left over? 1. Oh, 1 plus 1. And then I have to put plus 2. Why am I putting this plus 2 at the end? Yeah, that was there already. Now, is there anything else that I can add on this line?
1 and 2.
1 and 2. Can I add these two together?
Yes.
She says yes.
No.
Why can't I add those two together?
It's 3A squared.
Yeah, one is an A squared and one is an A. These two cannot be added together at all. So I have A squared plus 2A, but I can add the 1 plus 2, which is going to give me what? 3. So that's my answer. And put it in the box. Okay? You can only add A squares with A squares, A's with A's, numbers with numbers. Otherwise, you just leave them where they're at. Okay, look at B. Now notice I left H and G for you to do. Okay, notice I left H and G for you to do. Okay? It says in the function notation x comma f of x, which f of x is still just what letter? No, what is f of x? Y. Which symbol represents the domain? Which one's the domain? X. we say X is the domain. So that doesn't change, does it? Which one represents the range? That's correct. Right? Same exact thing. What are the benefits of using function notation? What's the difference between me using a Y here and using an X here? Yeah, you'll know what points I'm putting in. So you will know the value. And we have to write a complete sentence. You will know the value of your domain to find the what? Not the slope. What are we finding? Range.
Are you gonna give us that section over, Jonathan? Or you gonna go to the note?
How come everything do it here? Later here.
What?
Oh, later not there.
All right. What are you going to do for number 4? What does it tell you to do?
You gotta graph all your,
You got to graph all the points, and it's going to ask you to do what?
you got to label.
What does it ask you to do?
Label the axis, the coordinates, and the part of the coordinates on the other.
Yeah, we're going to have to label the domain. Which one's going to be the domain? What's going to be the domain?
Your smallest number.
Nope.
Or negative.
The first number. It doesn't have anything to do with negative or positive. All it has to do is the first number, which are our X values. What are going to be your ranges? The second number, which are our Y's or our X's. Now, how do I know if the relation is a function or not? Which ones cannot repeat?
Cannot repeat.
Cannot repeat. The X's or the Y's. Which one cannot repeat? The X cannot repeat. So if I go through here and none of my X's repeat, then I know that it's a function. Okay? How do I know if it's continuous or discrete? Yeah. Is it asking us to connect those points? No. So will it be continuous?
No.
It's going to have to be what? Discrete. Okay, let's go to the next page.
Oh, we're not gonna do it?
No, that's your homework.
Oh, okay.
Well, you should get done with most of it in class.
Oh, yeah.
You should. All right. This next page, we're going to do the same exact thing. By the way, is this continuous or discrete? It's continuous. How do I know?
Because it,
Yeah, it has a starting point and ending point. It may not look like anything, but it has a starting point and ending point. What about this one?
continuous.
It's continuous
I
also.
spit it out.
Continuous also. Continuous also. How am I gonna figure out what the domain and range of these are? The first point, where is this started? And the last one. Gotta give me domain. How am I gonna figure out what the range is?
So,
Do I go from top to bottom or bottom to top?
bottom top.
Bottom to top.
I have one question.
Yes, sir.
On that domain, domain, you got your both points, so which one would you do?
Yeah, you start at here, whatever this number is right here.
Yeah.
Whatever that is, you put it here.
Okay. You put that one there.
You put less than x less than, and this is going to be equal to. Why is this one just less than and this one's equal to? What's the difference between this point and this point?
Because one's the starting point.
No, it doesn't have anything to do. What's the difference between this point and that point?
That is continuous.
No.
One's open,
One's open, doesn't, isn't this one not colored in?
oh, yeah.
And this one's colored in? So you have to leave this one open, and then you put the other number here. Same thing for your y. You're going to start off with the number that's on the bottom. Whatever it is, I don't know what it is. And then instead of putting the x, I'm going to put a what? And put the other number. Whatever it is at the top. What about the domain over here? Can I do the same thing? Do I have a starting point and an ending point? No, I have a right. I have a starting point. Everybody sees I have a starting point. And it starts somewhere. So I won't have an interval. This is called an interval, where I have a starting point and an ending point. Here I just have a starting point. Let me ask you this. On this graph, are my x's getting bigger or smaller? Bigger. So I need to put a what kind of symbol? Greater than equal to. What about y? Is my y getting bigger according to this graph or smaller?
Bigger.
Bigger.
Greater than equal.
Greater than equal to. Whatever the number is at any time. Everybody follow me? And then you gotta tell me if it's a function or not and all that good stuff. Next part. I think it's the last page. You're gonna need to calculate this part. And you want to do this part first, you have a calculator, okay? Now when you fill in the tables, when you go to your calculators, you want to go to y equals. Let me show you how to get there. You want to go to y equals. And then you want to put in the equation. The equation was what? 2, and it's absolute value. This is how you get to absolute value. You might want to write this down. You push your math button. You go over to number. And everybody see that ABS? You want number 1, or you can hit 1, or you can hit enter. And that's saying 2 times the absolute value. And it's asking you, okay, absolute value of what? What was it? X minus 1? I can't remember. So we go x, everybody see where x was at, where I put x? Minus 1. And then I close parentheses.
Right.
And then I don't need the graph necessarily yet. I need to fill in my table, right? So I want to put a second graph, because that's says table. And then I fill it in.
Okay. You do what?
Yeah, you can move, and to move it up and down, you just move your arrow keys. Okay? And you find the number that they ask you for. I don't even know what number they ask you for. Whatever it is. Alright? Do you have any questions? Let me clear this off my next one.
Can we start?
You may start, get your calculator, move your desk around. Do not sit down and waste your time.
I'm not.